Okay, magandang araw po sa inyo lahat. Uh, Good afternoon, everyone. So we're going to start this new um, webinar on ESEA, meaning to say Electrical Safety Enforcement and Awareness. So because the month of May is Electrical Safety Month, so we would like to take advantage of these remaining days of May so that we can also inform the public and safety in electrical system. So in the past, there has been a lot of tragedies or incidents or accidents involving electricity. So we enjoin everyone to uh, watch this video and also share it to your friends and relatives and your neighbors and to colleagues in the community. Okay, so we start with our prayers, our invocation. Amang banal, pinupuri ka namin at pinasalamatan sa mga biyaya at sa tuloy-tuloy mong paggabay sa amin. Maraming salamat po sa pagkakataon na makapaglingkod sa aming mga kapatid at sa aming bayan. Sana po magawa nito bibigay ng dagdag na kalaman, kakayahan at kaunlaran ng bawat isa at para sa aming bayan. Lahat pong ito ay aming tinataas sa iyo, dakilang Ama, sa pangalan ng iyong anak na si Jesus. Amen. Okay, so this is my short resume, and I'd like you to just refer to it. I've been in electrical practice for over 45 years, and in other disciplines like mechanical and plumbing, I have shorter experience, but all of this experience has enriched my career and my, of course, my expertise being a professional engineer and doing a combination of mechanical, electrical, plumbing, and fire protection practice has made me more knowledgeable and very observing when it comes to safety in general. Okay, so I presently operate a small company, FEM Safety Engineering and Construction. I used to be the chairman of the Electrical Safety Committee of the Institute of Integrated Electrical Engineers of the Philippines, and I became the national president of the Association of Master Plumbers or Plumbing Engineers, and I've also been into volunteerism, having been a national president of Lawin, Philippines for 3 years from 2009, 2010, and 2011. And of course, I'm also a Rotarian, having been a president in 2005, 2006. So, let's proceed. What's the history of electrical safety? So, ever since the Americans have, I would say, invented electricity when Thomas Alva Edison, the great American inventor, started to, or she developed the incandescent bulb or invented the incandescent bulb. So at this point in time, since the light or the bulb is the simplest means that you could use electricity, because at night time you would be able already to illuminate your place, your home, the streets, and so on. So it has been a great breakthrough in our civilization. Of course, could imagine people before the advent of the incandescent bulb still use the lampara, still use the lamp with the kerosene, or maybe use the candles. But with the advent of electricity, they started to provide light. So, of the first electric companies in the world, like say in Manila, the Meralco, Manila Electric and Railroad Company. It means Manila Electric Railroad and Light Company. So even in Davao, there's the Davao Light and Power. So it was initially the provision of lights as the best or the easiest to provide service from electricity. Of course, there were already some small motors maybe that has been handled, like a motion picture, like the phonograph, and some other applications. But in those times, in the um, late 1900, no, the most of the prime movers used um, mechanical engines yet, no, not yet the electric motor. Okay, so here we would like to refer you to this slide. It's not, might not be very clear, but as you would see, it was in 1860 when the first fuses were developed. So if you remember, in the Philippine history, um, Dr. Jose Rizal was born sometime in this period, no? If I'm not mistaken, he was born in 1863 or 1861. So it was this time of history of the world was really very important, no? And then in 1880s, AC DC electrical systems were expanded. Okay, and in 1889, electric chair was developed. Okay, so even at that point in time, maybe there were already many criminals, and they had to met out a punishment to these criminals. No? Instead of hanging them, so they invented the electric chair, and that was 1889. So 1890, the circuit breakers were developed. Okay, and in 1897, that was just a year after the Katipunan was exposed in August 23, 1896. No, the first NEC, what is NEC? National Electrical Code was released. So you see, in America, they already have an electrical code as early as 1897. That was the time when the Philippines was fighting for independence. See, we only got our independence declared by Aguinaldo, President Aguinaldo, in 1898. See, so let's see. Then UL, 1897, UL is formed. What is UL? Underwriters Laboratory. So this is a testing laboratory in charge of subjecting materials to testing to ensure higher standards. Okay, and in 1913, a little jump in the time, no, the first edition of the electrician's handbook was made. See, and in the 1940s, that was before during the time of World War II. Okay, 1940s, the current limiting fuses were developed, and in 1970, the Occupational Safety and Health Administration of America was formed. So it was only some 50 years ago when this was formed. Okay, in 1979, the NFPA 70E was released. So what is NFPA? National Fire Protection Association of America. So see, that was the progress of technology when it comes to electricity. Okay, let's see the next slide. And here's the next slide. 1980, first burn centers open. So because there were already problems with the improper use of electricity, there were already short circuits, maybe electrocution, and so on and so forth. So there were already the accidents. So they put up the first burn centers. It's not yet really, let's say, a hospital or what, no, but burn centers to treat those who might have met accidents in electricity. No, so in 1982, Ralph Lee's arc flash paper came out. What is this arc flash? Arc flash is an explosion caused by electricity when you have two lines. The power from one line to the other would jump to the other line, and it might cause burning or explosion, or so a fire could happen also. Okay, so in 1990, the OSHA, Occupational Self-Healthy and Health and Administration, so Part S was updated. No, so there's that portion is there. No, so safety, S is safety, H is health. Okay. In 1995, NFPA 70 recognized arc flash. Again, arc flash is this dangerous thing that caused by electric short circuit. In 1995, arc resistant switchgear were introduced. So that means that because of this arc flash, many manufacturers and even American standards provide for this arc resistant switchgear. What has been causing this arc flash or this short circuit, this jump of electricity from one line to the other? And in year 2000, NFPA 70 expands the arc flash. Okay, and in 2002, National Electrical Code of America requires the warning labels to be marked. And in 2004, the NFPA 70 is expanded and revised. And in 2005, the NEC is updated further. So there's a continuing upgrading, and you might know very well that Americans in America, they continue to upgrade their national electrical code, and so with here in the Philippines, our electrical practitioners also continue to upgrade the Philippine electrical code, which is of course generally based to or with the American national electrical code. We being a colony before of America, so in the early half of the 20th century, we just merely use the National Electrical Code of America. Okay? So here, a history of electrical safety. In 1911, the NFPA was asked to take over administration of the National Electrical Code of America, which had been started by the Underwriters National Electrical Association in 1982. Certainly, the NEC is an important publication of our association, and its publication year is yet more evidence than the system of consensus-based standards writing not only works but is at the same time the most democratic form of self-regulation in the United States. Okay, so and so on and so forth. So okay, and now we proceed with this slide, which shows us that tatlong kalalakihan patay matapos na makuryente sa kinukumpuning water pump. So this happened in San Boga del Sur last year, July 30, 2019, last year. And 3 men were supposed to do some servicing for a deep well. No? So this is the deep well casing. And suddenly they collapse. So it is possible that these men were electrocuted. Why? Because maybe they were not conscious, knowledgeable, or with regard to electrical safety, like isolating power, which might have probably grounded the pipe or the motor or whatever. No? So 3 people died. See, so every now and then these electrical accidents do happen, and lives are lost. So that's the reason why we would like to conduct this webinar, so that most people would be aware of it. Okay, so here is a slide that shows us when your hand touches an live electrical conductor, the electricity would pass through the body, through the hands, of course, and it will exit through the foot to the ground. It will pass through the body into the ground, and it might pass through partly the heart, or as indicated in the schematic. And the moment it passes through the heart, then there is a possibility that the heart might stop beating and therefore might kill a person. Okay, so again, let's see. This is a 2014 accident. This is a graph from Facebook. September 19, 2014. 3 tao sa Maynila na kuryente sa gitna ng masamang panahon. So, what happened here is that 3 young men were cruising the Espanya Street in Sampaloc, Manila. And the Espanya Street was flooded. It's flooded as usual, and they were waving through the flood. And upon touching the metal railings of the islands, suddenly they got electrocuted, and they died instantly because of the electricity is too much for their body to be able to. So there's something lacking in here. I believe there's been this lacking ground fault circuit interrupter, because the moment you have a ground fault, it should be this GFCI, or ground fault circuit interrupter, or an earth leakage breaker that should isolate electricity from the non-current carrying parts, like for example the metal railings, okay, or the posts, the lighting post, the metal of the lighting post. Any metal which is a conductor of electricity will become a possible path of electrocution of the electricity, which, like we mentioned earlier in this sketch, no, that the current would pass through our body. So, in other words, there was something lacking in here, in that installation there in Manila. No, how come? So that means that in our present practice as electrical practitioners in the Philippines, um, there are three possible people that could have made a mistake. Number one, it could be the engineer who prepared the electrical design. He might have missed specifying, including in his design, the GFCI, the ground fault circuit interrupter. Secondly, the engineer who is supposed to supervise the project also missed to provide this. Even if the designer did not provide it, if the inspector or supervisor, electrical supervisor, is knowledgeable, he knows his code, the electrical code, his safety, he would have uh, con- coordinated with the designer to include this provision, safety provision. Okay, supposing both the designer and the supervisor uh, miss it, then there's the third person supposedly that should be able to check this, and this is the electrical inspector from the city hall. So again, all the three gentlemen, three people, did not have the you know the knowledge or skill, or to provide this electrical safety device, the ground fault circuit interrupter. So up to now, there is big problem with the electrical practitioners in the country. Many are still lacking in the real uh, expertise when it comes to electrical safety. See, this is another picture. We took it from the internet, showing that this guy would be digging, struck a cable which might have damaged the insulation of the cable and got him electrocuted. Okay, so we must be careful when we are digging uh, um, outside. No, we should be very careful. We should get the plans, refer to the old plans, as-built plans, so that we would know if there are lines, or if not, we should use detectors to find out if there are lines traveling underneath the location of your excavation. Okay, and here another picture shows us that the lineman also suffered electrocution. Huh? Linemen are those people working on the overhead power lines, just like the Meralco lineman, the Veco lineman, the double light and power lineman, and so on and so forth. So they must be very careful also. It's possible that this lineman missed uh, de-energizing a power line, or it's also possible that a person in the company inadvertently switched on the line, which might have electrocuted this person. So again, we must be very careful with this. Okay, so here is another cartoon comics drawing. Shows that this guy doing the jackhammering might have struck an underground line, which shut off the power of this lady here. Where's my electric? Where's my plan? So again, it doesn't know that there are lines passing through it, and this work journeyman struck it, no? And possible also that he could get electrocuted. So we must be very careful. Okay, in 2010, there was this Tuguegarao bed and breakfast uh, fire uh, happened in Tuguegarao, December 19, 2010, which killed 16 people. So the owner of this building is the same as the owner of this. This on the right side is the hotel building, bed and breakfast pension house, and this one is their hardware building. So the fire started here in this left building, and then the smoke went even to the hotel building, and that suffocated many of the occupants here, and many died, including several nurses who were supposed to take the board exams in Tuguegarao city at that time. Okay, and here is a picture of that. You would see that in that Tuguegarao bed and breakfast hotel fire, in the hardware, that's the left building, there were so many uh, canisters, no? Here you would see them here. This one, this one, this one, this one. So many of them scattered in the debris of the fire. So that means that these aerosol paints canisters contain flammable materials. No, it could be uh, paint thinner, it could be lacquer thinner. So the moment you remove the cover, there's possibility that the compound inside the paint could burst or could go out and start a big fire. So we believe that that was the big reason why it happened, and I just don't understand why the owner would stock so many of these aerosol cans, no, aerosol paints in her room where the cash register was located. So this room was in her cash register room. So any flammable substance, like for example alcohol, kerosene, gasoline, LPG, anything that are flammable, should not be stored inside our rooms. No, they should be just stored outside where there is plenty of ventilation, so that the possibility of explosion inside the where we are living should be very far. No, should be, so even your kitchen should be with adequate ventilation. If you have LPG fuel, like PG tanks being used for cooking purposes, the LPG leak will just be scattered there. No, okay. Here's a picture of the Cantex fire, the entrance of the factory, and here was a scene of the picture of the scene of the fire. At this portion where sacks of raw materials which were flammable were stored, and somebody was doing welding on the main gate, and the sparks from the welding would go to the uh, flammable materials, okay, that were stored here, and then they were ignited, and the people there were not ready to put off the fire, and the fire was so big that it trapped the workers of Kentex here, could not just go out, could not escape it, because there are no fire escape in there. So again, there was a lapse in that welding, not getting the right permit, and then there was no also no fire escapes in the buildings, totally enclosed. No? So that killed a lot of people, something like over 70 people. Okay, and here's a picture of that building in Serendra in Bonifacio Global City, where a big LPG explosion happened. So you would see the walls of this 6th-floor condominium unit, which was shattered after this very strong explosion. So see, it is very dangerous to have gas leak inside. No, what happened here is that these people in uh, what you call this the developers of these condominium units in Serendra made or included LPG as the fuel for cooking. So instead of putting their LPG tanks on using LPG tanks, they used pipe gas, and the problem was there was this leak, and the detector wasn't working all right. So detector and also the automatic shut-off device wasn't working all right, which caused this big explosion. This is on the sixth floor, so very dangerous. We must be very careful when it comes to handling liquefied petroleum gas. And this is another one. In 2007, this happened at the Glorieta 2 explosion. No? Glorieta 2 in Makati. 11 people died, and what happened is that there was this leak gas, not LPG this time, but methane and hydrogen sulfide that were accumulated because of in the sump, no, in the basement, because the what you call this, the sump motors, the transfer pumps, the sump motors, at a time were damaged. No? It was believed that the running pump was damaged. It wasn't, and then of course they used the standby. For a while they were not the maintenance people were not able to replace the first one until the second one, the standby sump pump, was also damaged. So again, it was still not properly replaced or maintained until it accumulated. No, I mean the methane gas and the hydrogen sulfide, which just waiting for ignition or an arc, or a spark. And when this happened, you would see the very big devastation or damage that happened in the building where 11 people died. So again, must be very careful as well. And this is a picture of the Resorts World in 2017. A gunman went inside and started shooting. So the playing patrons were afraid to come out, so they had to seek shelter in rooms inside, even kitchen rooms, etc. And as the guards and the military, the police were trying to control the gunman overnight, the gunman also poured gasoline in the playing tables, like here. You see here in this picture, you see these are the playing tables. He would pour gasoline or kerosene and ignite them. He would also do this in the slot machine area, thereby producing carbon monoxide, or because the fire is not complete. Carbon monoxide is produced when the fire is not completed. No, if a fire happens outside of a building, chances are the product of the fire is carbon dioxide and a little of those toxic gases. But in the case of a fire inside a room, a building that is enclosed, so not openly ventilated, so when the fire happens, and especially when not there is no complete combustion that happens, like in this, it just starts the fire and then would stop. No, it won't continuously burn, thereby producing carbon monoxide. So later on in the next morning, the people there, the guard, the security people, would locate the people, about 37 of them already called dead, and And there's only one reason, and that is the carbon monoxide which was produced and it was scattered in those rooms where these people stayed by the air conditioning system. So, uh, so many of these accidents, those still do happen, and we need to be very careful. We need to be uh, to increase awareness when it comes to this system, this electrical safety, so that we should be able to lessen these accidents. Okay, here in the Philippines in 2011, in January 12, 2011, the IIE team of electrical engineers was requested by the city prosecutor of Tuguegarao City to submit an independent technical investigation evaluation of the cause of the bed and breakfast hotel fire that killed 16 people. So at this point in time, I was yours truly was the chairman of the electrical safety committee of the IIE, and then the national president at that time of the IIEE was Engineer Armando Diaz. So he formed a team. Engineer Diaz formed a team of investigators, technical investigators, to go to Tuguegarao to conduct it. And after that, after the investigation, we submitted to the um, city prosecutor's office our findings, which eventually pinned down those who made mistakes in the inspection, in the installation, and so on and so forth of these two buildings, that bed and breakfast and the hardware buildings owned by the owner. So there were a lot of violations of the code there. No? So in May 21, 2011, the IIE launched the Electrical Safety Enforcement and Awareness campaign. Okay, so we were able to get an approval from the President of the Philippines at the time, and that is President Benigno Simeon Coangco Aquino, issuing the proclamation number 193, declaring the month of May as, and every year after, as the Electrical Safety Month. Okay, so next, and here is just a portion of the proclamation, the proclamation order by President Noytoy. This is his signature, and also the signature of the executive secretary at that time. Okay, and it included this, no, Presidential Proclamation number 193, declaring the month of May as, and every year as, the Electrical Safety Month. Whereas many lives and properties are lost due to fires and electrocution. Okay. Whereas most of these fires and incidents of electrocution are attributed to faulty electrical wiring. Okay, and let's continue. Whereas the main reason for the occurrence of fires and electrocution from electrical causes is not faulty wiring, but ignorance in the use of electrical appliances and gadgets, such as overloading of electrical outlets and the use of counterfeit electrical products such as circuit breakers, power strips, extension cords, batteries, holiday lights that can cause fires, can overload, explosions, shocks, and electrocution. Whereas there is a real need to increase public awareness in electrical safety, and holiday lights that can cause fires, can overload, explosions, shocks, and electrocution. Whereas there is a real need to increase public awareness. Whereas the Bureau of Product Standards, okay, okay, the Bureau of Product Standards under the Department of Trade and Industry is the national standards body of the Philippines, mandated to develop, promulgate, implement, and coordinate standardization activities with electrical products. Whereas the Institute of Integrated Electrical Engineers of the Philippines has entered into an agreement with Singapore-based International Copper Association, Southeast Asia, that is the ESEA, a non-profit organization, to conduct electrical safety awareness campaign in the country and to provide the opportunity to share the best practices and help establish good standards in electrical system in the Philippines. Whereas an electrical safety month in May would amplify and reinforce consciousness on electrical safety. Okay, so therefore, the ESEA mission is to ensure that this ESEA would be properly enforced through improving local inspectors' capacity and to increase the public's awareness on electrical safety. To be a major campaigner that leads the public towards an electrically safe environment. That's the mission, the vision of the ESEA. And the objectives are designed to enhance the enforcement of Philippine Electrical Code, provide capacity building to improve the skills of local inspectors, increase the awareness and educate the public on the importance of electrical safety, and strengthen the institutional cooperation between government and industry such as the local government units, developers, and contractors association, among others. So, okay, here is just a slide where this guy is unknowingly is carrying his ladder, but unknowingly is very close to the ladder to the overhead line above. Again, sometimes people are not very careful, not very observant, and even the Meralco would provide these warning in their trucks, no, upang iwas sa aksidente, huwag lumapit sa linya ng kuryente. Okay, keep away from high voltage lines. Okay, so the dangers of electricity: about 5 workers are electrocuted every week. This is a worldwide statistic. So, all parts of the world, especially the third world countries, have these statistics. No? Causes 12% of the young worker people workplace deaths. See, and takes very little electricity to cause harm. You don't need to have a big power, high voltage, and so on to cause electric shock. And there's a significant risk to cause fire. Okay, so very dangerous, because if there is a flammable substance in there, then chances are you might cause explosions. So, further, from the Bureau of Fire, 46,719 fires were recorded nationwide by the Bureau of Fire, and an average of 26 reported daily incidents do happen, no? And there are 4 main types of electrical injuries. There's the direct injury, which is the electrocution or death due to the electrical shock, and number 2, electrical shock itself. Number 3 are the burns, when an arc flash happen, no? The indirect injury is when you fall, when somebody electrocuted falls and break his leg or what, no? Okay, so the severity of the shock depends on the path of current through the body, the amount of current flowing through the body, that's the amperes. Okay, the greater the amperes, therefore, would be more lethal when the current is higher. And of course, the duration of the shocking current through the body. The longer a person is touching a live wire, so that means that electricity is passing through his body, then the more lethal it is, no? It doesn't mean that low voltage is of lower danger. No, what is really dangerous is the current that may flow through the body. Okay, touching wires, instant death, $200 fine. So I think Newcastle tramway. So this could be in Hong Kong. Touching wires causes instant death. $200 fine if you touch wires. Okay. Dangers of electric shock. Currents above 10 milliamperes can paralyze or increase muscles. No, see, so even very small amount of currents. No, this is about point point one. No, point 0.1 ampere. So very small amount of current. No, currents more than 75 milliamperes can cause rapid ineffective heartbeat. So it can stop the heart to beat, no, the moment electricity passes through our body. Death will occur in a few minutes unless a defibrillator is used. No, 75 milliamperes is not much current. A small power drill uses 30 times as much. So see, a small electric drill has a higher current flowing into it, no, than this value of 75 milliamperes. Most common shock related injury is of course when you have a boil, no? Of course when you touch an electrical wiring equipment that is improperly used or maintained. And then typically occurs on the hands because it is the hands that usually touches things, and if you are not careful, again you'll get electrocuted. Very serious injury that needs immediate attention. Okay. Severity of shock depends on voltage, amperage, and resistance. Lower resistance causes greater current. So, okay, and this is what was discussed in the first slides of this presentation. When you see when arc class was mentioned, it means about the jump of power, electric power, from one line to the other. No, so if there are two lines, so that's what we call arc flash or short circuit. So we must be very careful. And here is a picture of an engineer who was exposed to an arc flash, no, and a big short circuit. The heat generated could be up to 4,000 degrees Celsius in magnitude of heat, and hot enough to vaporize metal and ignite victims' clothing, and causes third and fourth degree burns. So very dangerous. As you could see, the ears of the person are maimed, okay, and even the face, I believe. No? So it's very important, therefore, that electric personnel must wear this personal protective equipment, thick enough to protect the person, even with the goggles here, no, and with gloves. So if there would be an explosion, he would be protected. And high voltage is not a joke, you know. You see here, this guy maybe is out of his mind, is trying to climb an electrical post where there are high tension line here, suddenly burst in flames. So yan, very dangerous. Okay, current flows through the body from the entrance point until finally exiting where the body is closest to the ground, and it only needs 23 milliamps in this other graphics that can kill already a person. Okay, here are the safe approach distances. No, approach distances for qualified person. This table applies to overhead lines but may be used to develop local guidelines. So for practitioners, voltage range 300 volts or less, you should not touch it. No, never you should touch it. So, and then higher than 300 volts and not over 750 volts, the distance should be 12 inches or 1 foot, and 750 volts to 2000 volts is 1 feet 6 inches or 46 centimeters. 2,000 volts to 15,000 volts is 2 feet or 61 centimeters. 15,000 volts to 37,000 volts, this is the voltage of the power lines of the Meralco. So it should be 3 feet. So beware, your window, if the high voltage line is close to your window to your house, then you have to be very careful. No? You have to report this to the Meralco utility company so that they could do something to provide an insulator on that part of the line. So much higher voltage, farther distances. Okay, so that's only the minimum. So you are not supposed to get closer to that. Okay, and here is just again an illustration how to protect yourself. So here, if the equipment is here at 480 volts, the restricted distance is up to here, which is 12 inches. And for somebody knowledgeable is here, up to 42 inches. And for a non-knowledgeable person, must be farther enough, no? Farther enough from the electrical equipment. Okay. Okay, so let's continue. Now we go to the hazards identification. Okay. You know, it is better to be careful 100 times than to get killed once. That is according to Mark Twain. Because the moment you are electrocuted, then there's no more you. Okay, so be careful when installing solar panels. You have to get licensed electrical practitioners to be assured that your installation will be safe, electrically safe. And here is the proper use of protection circuit breakers. No? We have to select the correct protection. So this is for practitioners. Sometimes many practitioners are really not knowledgeable, make a mistake of providing protection, circuit breaker protection, trip setting that are higher than the correct values. No? So this is an example. And this is an example again. There is this feeder wire coming in to the fuse disconnect switch, but the fuse is very high, 200 amperes as against the ampacity of the wire. The capacity of the wire is only good for 70 amperes, but the fuse is 200 amperes. So it means therefore that there's a possibility of overloading the wire because the protection is too high. No, the protection should be just enough to be equal or almost equal to the capacity or ampacity of the wire. Okay, here is a reference for the kind of wire. So here, these columns indicate the amperes capacity for each size of wire. Like for here, 2.0 wire, 25 mm for a THHN or THHW, and so on. A 3.5 mm, a bigger wire would allow 30 amps. No? 5.5 mm wire would allow 40 amps only. 8.0 mm wire should allow up to 50 amperes. Okay, and 14 mm 55 amps. 14 mm 70 amperes, and so on and so forth. So yeah, you have to be very knowledgeable in the selection of wires, and of course the protection. Again, this was a slide earlier shown in the earlier part of this PowerPoint. You see, this is a rewiring done by an electrician, but it is not correct because the wiring is too shallow. No? As you could see, the conduit and the embedding, no, yung lalim, the embedding of the wire on the conduit is too shallow, which therefore is not correct. And of course, the one who made the rectifications combined this PVC conduit and this metallic conduit, which is not a correct way of doing the wirings. Okay, here is a slide showing our kitchen sink, which shows us so many appliances, no, with only one outlet. So we should refrain from having only one outlet in the kitchen counter that has so many appliances. According to the present, the latest provision of the code, if your kitchen counter exceeds 2 feet, so you must provide another outlet. So 2 outlets should be provided, no, in excess of 60 mm or 2 feet. Okay, so but the real reason is, of course, if you have this much many appliances like a rice cooker, microwave oven, a mixer or osterizer, a bread toaster, coffee maker, and so on and so forth, and you have only one outlet, chances are they will not fit into your outlet. So you might use this what you call this multiplier outlet, and that will become a violation, and that is octopus connection. So we should refrain from doing it. We should ask our electrical practitioner to add another outlet to make it a lot safer. Okay, again, this was a picture earlier shown already, the Serenda explosion. What happened is that there was no correct functioning of the LPG gas detector, which made use of just plugging it, which is not correct. You know, this detector should be permanently connected to the electrical system so that there would be no inadvertent removal of the plugging. No? That's what happened with the Serentra 2 explosion. LPG tank should be installed outdoors in a safe place, provided with this chain guard, so as not to inadvertently allow them to sway or to fall down when there is probably a strong earthquake. No? Okay. Again, this was the Glorieta explosion. And okay, here the lesson here is we should not use the front of our electrical protective devices, our electrical panel boards, as display of our trophies or whatever. No, the code says that these breakers or electrical panel boards should be readily accessible, and by providing this display of trophies as well as glass covering is a violation of the code. Okay, so panel board should be provided with cover so as not to allow foreign bodies like this animal to enter and can cause problem. No, this animal beat the bus bar here, and then he's grounded. See, so very dangerous. And of course, proper installation of conduits. This is not the correct way. When it rains, water would enter the electrical panel, and it would also cause electrocution of somebody that might touch the cover when it is wet. So not incorrect way of installing the panel. And here you must be very careful when doing wiring at heights, because you might fall down. Okay. Electric shock can also cause indirect injuries. Workers, people in elevated locations who experience shock may fall, resulting in serious injury or death. So we must be careful. We must make sure that our stairs are stable, okay, ladder, and also we must use body harness, no, so that we cannot just fold them, especially when the elevation is quite high. No? Okay, this kind of installation is not correct because uh, the wires are just simply flying, so it's not, it's dangerous. Somebody might touch it, or it might also cause deterioration of these wires. Okay, the splicing was simply done on the terminals of the plug, so it's not correct. Okay, electrical accidents are caused by combination of three factors: unsafe equipment installation, workplaces made unsafe by the environment, and unsafe work practices. Okay, there are also installation that you would see is not properly done, magulo. Okay, and here you would see uncovered holes. Again, some foreign bodies might enter and might cause grounding or short circuit, so you have to be careful. Again, this one, this box, metal box, is already rusted, and there are no covers also. Again, that might allow foreign bodies, animals, rats, and others that might come close to it or even damage the insulation of the wires. Okay, so they should have covers. Overhead high voltage line, we should keep away from them. Very dangerous. You may never know when the lines would fail and would drop down. Okay. Wires should be inspected regularly, especially those that are exposed, to make sure that there are no fray into it and nobody will get electrocuted, especially when water would tend to when it is exposed to water or to the rain. Okay, cords can be damaged by aging, door or window edges, staples or fastenings, abrasion from adjacent materials, and so on. No? Do not use flexible wirings where frequent inspection would be difficult to do. No? Okay, where damage would be likely, and flexible cords must not be run through holes in the walls, ceilings, or floors. Run through doorways, windows, similar openings unless physically protected, and hidden in walls, ceilings, floors, conduit, and other space. So, okay. Grounding creates low resistance path of from a tool to through the earth. So again, usually our plug is provided with a ground lug. So our home run, circuit home run, should have a grounding connection. So that will protect the personnel working with a portable tool like this one. So sometimes we cut it, no. So that's not a good practice. No? Okay, so here is a schematic that when this person touches an enclosure that is not adequately grounded, he gets electrocuted. Okay, so we should avoid cutting the grounding electrode like this one. Okay, what's correct is to provide the grounding in the wire. Okay, and we must use the GFCI. Remember that in the earlier part of this presentation, you have the accident that happened there in Zamboanga, as well as in España, okay, in Sampalo. So the circuit did not provide for a ground fault circuit interrupter, and therefore it created a problem. Okay. Hazards may result also in this kind of installation, where it is very, it looks like it is temporary wire installation, but it's too dangerous, And again, like I mentioned, old wires must be inspected, and if it is possible to cover them with electrical tape, we must do so that they may not be exposed to moisture or water or to people, Okay, we should not play with this kind of I know this is a joke, no? There's this outlet and a floating there's a floating outlet and a pond, no? So it's too dangerous. It might cause electrocution of these people, no? And in the past there has been incidents that were that happened, especially one in, I remember, in Mandaluyong, in a hotel, I think, and also in Makati, again in a building, residential building with a pool, okay, where it is possible that the lighting circuits and some other wirings might have got wet, and there are no ground fault circuit interrupter provided, and therefore uh, pose danger to those people using the swimming pool. Equipotential grounding is very important to make sure that those who are using the swimming pool, may not get a shock, electric shock. No? Fire tragedies in the past. Let us look at them. One of the biggest fire was the Manor Hotel fire in 2001, and it was caused by an electrical short circuit with about 75 people who died. Okay, with another 73 people injured. So Manor Hotel is located along Canyas. Okay, so and it's a picture of the Manor Hotel. Again, additional pictures showing the damages of the feeder that might have been overloaded. And these were the findings by the Bureau of Fire of the Manor fire. See, no automatic sprinkler system. It is a hotel, so if it is a hotel, sprinkler system should be mandatory. There is no the standpipe, the fire water standpipe is also defective, and also the manual fire alarm system is also defective, and the road to fire exit is also obstructed. So when we must clear ways. We do not know when emergency would happen. No? Inadequate secondary stair or fire exit, no smoke and heat detectors, inadequate portable fire extinguisher. So these were the findings of the Bureau of Fire in the Manor Hotel fire. Then there is this association, the Damas de Filipinas fire, Paco Resettlement House. It happened in 1998, December 3, and it was caused by an electrical short circuit, and 53 persons died and about 10 million in damages. So again, very unfortunate because most of the fatalities were children. And the Lung Center fire also in 1998, May 16, was caused by, again, electrical ignition, constant grounding, and 27 people died with almost 700 million damages. Okay, but the worst was the ozone disco fire in I think that was 1996, and it was caused by overloading, and 162 persons died, and what aggravated the situation was that the problems in architecture, like for example the doors were, instead of swinging out, they were swinging in. Before you can exit, you have to pull the door in. So that was the thing that was wrong, and of course there was overloading, overcrowding also, and it trapped those young people who were celebrating their seniors prom in 1996. It's a picture of the fire. Okay, just a tabulation of this. So the ozone disco, about 15 million, 162 persons, and it happened in March 19 of 1996. Okay, So here is a photo album of some violations again, just to remind us. So here is a dirty installation. So it's possible that dirt would come in contact with electricity, and when when during the rainy season, this dirt could become moist and therefore would cause grounding or electrical short circuit. Here is a picture of an electrical panel board which was submerged to flood waters during the typhoon Ondoy in 2009, and it was never cleaned before they were uh, energized or used again. So again, lack of maintenance is the problem here. So nobody went to do the real maintenance before they were put back to uh, service or use. Here is a temporary wiring. Could be a public works project. So the temporary wiring just simply make use of open wires. You know, in public works, you should be using royal cord, or in other words, there is a double insulation of the wires, not like in this situation where you see the wires are just simply being used as such. So it's so dangerous that in the long run might cause grounding and could cause electrocution. So with this is done outside without proper construction of a safety manhole, electrical manhole, dangerous also. And here, the technician who did the works just simply cut some of the strands of the wire, as you could see, no? Because the wire is quite big, he would cut some of the strands so that he would be able to fit in a few strands on the terminal of the circuit breaker. So this is a violation of the code. Here is also a violation of the code because the installer just simply did not provide for a firm connection of the conduits. This is a coupling, so it's already being detached from the conduit and therefore exposing the cable or wire. Okay. There's also another one where splice are exposed, so very dangerous. They should be provided with electrical tape or splicing tape, so to prevent from possible short circuit or electrocution. And again, this should be uh, avoided using this kind of temporary portable outlet. Okay, it's a more professional way, safety way of providing for an extension cord. And similar with this, the installer just simply provide for a temporary manhole or pole box, which is not which is improper. And so with this, you would see these conduits already almost being damaged because this flexible conduit is not a standard thing to use outdoors, like in this case. PVC should use the rigid PVC and should be embedded in concrete, a minimum of 6 inches cover of concrete. And so with this, the installer did not provide for or did not put all the splices inside and provide with cover, so that it wouldn't be exposed to the weather and to to danger. So with this, no proper splicing or mechanical protection of the wires. This one also, and this one also. The electrician made a mistake of combining the use of I think electrical conduit with water pipe, which is improper. Here, so somebody was doing excavation works and hit the conduits. So here you could see holes on the conduit, thereby possibly exposing the one who is doing the demolition of the concrete. by possibly touching the wires inside the conduit. Again, this one is the installer did not make it very firm so that the connection of this coupling to the pipe would be very firm. And here is an improper use of the jumper. The person involved in the maintenance just simply use a tube, a copper tube, to as a fuse, which is incorrect. No, therefore this installation doesn't provide any um, safety anymore to the load or to the feeder downstream. And here should be avoided because doing electrical works like this one, he might fall and he might get electrocuted when he fell to the pole. Okay, so um, it's not the correct way of doing the job. No? There's a possibility that he might fall. Okay, and here is a transformer installation which is very low, and also the meters are very low, could be touched by people passing through the street. It's so dangerous. And this one is showing what you call this, a cable line which the driver of this truck through and touches the high tension line. So you must be very careful. We have to see what is around us before we do something like this. Okay, so what happened is that when the driver threw this hook, supposedly to tie the cable, the lugs, then it got the short circuit, and of course his truck got burned. Okay, so here is this photo album of good electrical installations, acceptable installation here, very clean, with color coding and very nice installation with a directory to properly guide the maintenance personnel to do it. And here, nicely installed panels with transformers. Okay, and here is again the wiring is color coded and very clean. Also, this one you would see the panels are properly installed and maintained. And here also with again the directory of the service. Okay, so that's it. So that's the last part of the presentation. Thank you very much for your indulgence, for following this electrical safety webinar. I hope you were able to pick up some things, and maybe you can share it, tell your friends so that they can also go back to this video and also learn. And do not forget to like the video, and also subscribe if you haven't subscribed to my channel. And you can also make your comments so that we can also answer them. Thank you very much, and have a nice day. Keep safe, not only against the COVID, but also against what not only against the COVID, but also against electricity, which is unseen, just like the COVID. Again, mabuhay.